All right, let's dive into something that's, well, it's pretty out there. We're talking about a theory that doesn't just tweak our understanding of the universe, it wants to tear it all down and start over from scratch. So, what does that even look like?
So our whole journey today kicks off with maybe the biggest question in all of science. You've heard it before, right? That almost everything in the universe, like 95% of it, is made of stuff we can't see, can't touch, and have never, ever found. But what if that's the wrong way to think about it? What if the problem isn't that something's missing, but that our whole approach to looking at the universe is just fundamentally flawed?
Okay, so to really get a grip on this new idea, we first have to talk about the massive problem it's trying to fix. And in physics, they have a name for it, cosmology's 95% problem.
Yeah, that number, that 95%, it really shows you just how much we don't know. Think about it. Our best, most successful model of reality, the standard model of cosmology, can only explain about 5% of what's actually out there. The other 95%, well, we just sort of label it. We call it dark matter and dark energy.
And it's super important to get this straight. These aren't just things we're still looking for. They're basically just placeholders. They're names we give to effects we see but can't explain. Our theories need them to exist for the math to work out, but we have zero direct evidence for them. That's kind of like trying to figure out how a car works when you can't see 95% of the engine. It's a huge problem.
So, because we're relying on these invisible parts, we've ended up launching one of the biggest and, most expensive treasure hunts in the history of science.
I mean, for decades now, we've been building these unbelievably sensitive detectors, burying them deep underground all over the planet, all just to catch a single one of these mysterious dark matter particles. We've poured billions of dollars into this, and the result? Absolutely nothing. Just silence. Sooner or later, you've got to start wondering, are we even looking for the right thing?
And that brings us to this really powerful conclusion from the source material. What if the reason we can't find any dark matter particles is, well, because they don't exist? What if the whole search, the whole idea has been wrong from the very start?
Okay, so this is where the whole story takes a sharp turn. If the old map is leading us nowhere, maybe it's time for a completely new map. And that's where this radical new idea for the foundation of physics comes in.
Right now, the standard model, the one heavily influenced by Einstein, sees reality as being made of two different things. You have space-time, which is kind of like the stage, and then you have energy and matter, which are the actors on that stage. The actors tell the stage how to bend, and the stage tells the actors where to go. But this new model, it says, nope, it's way simpler than that. There's only one thing. No stage, no actors. Just a single, unified thing called the elastic fabric of reality.
So in this new picture, everything, literally everything, you, me, the planet, the stars, we're not things in the universe. We are the universe. We're just shapes or waves moving through this single fabric. And the key word here is elasticity. This fabric isn't just some boring, static background. It's alive, it's dynamic, it can stretch and twist and vibrate all by itself. And those vibrations, that's what we call matter and energy.
Okay, that sounds cool and all, but how does this single fabric idea actually solve anything? How does it explain dark matter? Or, for that matter, how does it explain regular particles, like the ones that make up you and me?
Well, the answer for dark matter becomes almost stunningly simple. The weird gravitational effects we've been blaming on some invisible particle, in this model, it's not a particle at all. It's just a huge, slow-moving wave rippling through the fabric of reality. It's a geometric thing, not a substance. We couldn't find the particle because there was never a particle to begin with. We should have been looking for a wave.
And this idea doesn't stop with dark matter. It applies to everything. Think about an electron. We usually imagine it as a tiny little speck. But in this view, it's not a thing at all. It's a stable, twisted-up little knot in the fabric. Imagine taking a rubber sheet and twisting a tiny piece of it so tightly that it holds its shape. That's your electron. And all its properties, its charge, its spin, they're just features of that specific geometric twist.
But that brings up a really good question, right? If particles are just shapes, why are some of them, like an electron, super stable, while others fall apart almost instantly? The theory's answer to this is actually one of its coolest parts.
Let's take a look at the electron and its heavier, much more unstable cousin, the muon. Now, they're very similar in a lot of ways, which means in this model, their geometric shape has to be basically the same. So what's the difference? It's all about scale.
A muon is about 200 times more massive, and that's because its shape is made by twisting up a much, much bigger piece of the reality fabric. And this points to a really simple, intuitive rule. Imagine you're building something with Legos. A small, tight little structure is going to be really sturdy, but if you try to build a giant, sprawling version of that same shape, it's going to be way more fragile and likely to break. It's the same principle here. The more fabric a shape uses, the more massive it is, and the less stable it becomes. And what's amazing is that this gives us a physical reason for something we've seen for decades in particle physics, that heavier particles tend to decay faster.
So, if any of this is actually true, it's a huge deal. It doesn't just clear up a couple of mysteries, it completely changes how we should think about physics, from the ground up.
This new way of thinking basically splits our understanding into two layers. On the first level, you have the fabric. This is what reality actually is, this single, unified, changing object. Then you have the second level, and this is where all of our current physics lives. General relativity, quantum mechanics, all of it. The idea is that these theories aren't describing reality directly. They're just our best attempts to describe how the fabric behaves from our limited perspective.
And this is a really mind-bending shift in perspective. It suggests that things we think of as fundamental laws of the universe, like the speed of light, might not be fundamental at all. They might not be hard-coded into the fabric itself. Instead, they could just be emergent properties, rules that only look like rules because of our specific, limited viewpoint from inside the fabric. So our physical laws aren't telling us what reality is, they're telling us what reality looks like to us.
And that leaves us with one final, really big question to chew on. If dark matter turns out to be just a ripple in geometry, and if every particle is just a twist in that same geometry, what else have we gotten wrong? What other things do we think of as substance that are actually just features of the shape of reality itself? It kind of makes you wonder if the universe is both way simpler and a whole lot stranger than we ever gave it credit for.